Hello sir, myself Nitin Kumar, MTech first time CS. My topic of discussion is multimedia databases. Uh, this is the index, these are the topics which I will be discussing in this presentation. Introduction to multimedia databases, nature of multimedia data, and the nature of multimedia applications. Finally, the data management issues. Firstly, introduction. In the years ahead, multimedia information are expected to dominate our daily lives. Our houses will be wired for very high bandwidth to handle interactive multimedia applications. Our high definition TV, computer workstations will have access to a large number of databases, which includes digital libraries, image and video databases that will distribute vast amounts of multi-source multimedia content. Next, nature of multimedia data. These are the following types of multimedia data which are available in the current systems, which include text, graphics, images, animations, video, structured audio, composite or mixed multimedia data. I'd be discussing separately. Firstly, text. It's a formatted or unformatted. For ease of parsing structured documents, standards like HTML and variations such as HTML are being used. Graphics. Examples include drawings and illustrations that are encoded using some descriptive standards. For example, CGM, PICT and PostScripts. Next, images includes drawings, photographs and so on, encoded in the standard format such as bitmap, JPEG, MPEG. Compression is built into JPEG and MPEG. These images are not subdivided into components, hence querying them by content is non-trivial. Animations. These are temporal sequences of image or the graphic data. Next is the video. It's a set of temporally sequenced photographic data for presentation at specified rates, for example 30 frames per second. Next is the structured audio, a sequence of audio components comprising note, tone, duration and so on. Next is audio. Sample data generated from aural surroundings in a string of bits in digitized form. Analog recordings are typically converted into digital form before storage. Next is the nature of multimedia applications. Multimedia data may be stored, delivered and utilized in many different ways. Application may be categorized based on the data management characteristics as follows. Repository applications and presentation application collaborative work. Firstly, repository applications. A large amount of multimedia data as well as metadata is stored for retrieval purposes. A central repository containing multimedia data may be maintained by a Dbms and may be organized into hierarchy of storage levels such as local disk, territory disks and tapes, optical disks and so on. Examples include repositories of satellite images, engineering drawings and designs, space photograph and radiology scanned pictures. Presentation applications. A large number of applications involve delivery of multimedia data subject to temporal constraints. Audio and video data are delivered this way. In this application, optimal viewing or listening conditions require the DBMS to deliver data at certain rates, offering quality of service about a certain threshold. Data is consumed as it is delivered, unlike in repository application, where it may be processed later. Simple multimedia viewing of video data, for example, requires a system to simulate VCR-like functionality. Complex and interactive multimedia presentation involve orchestration directions to control the retrieval order of components. In a series or in parallel, interactive environment must support capabilities such as real-time editing analysis or annotating of video and audio data. Collaborative work using multimedia information. This is a new category of application in which engineers may execute a complex design task by merging drawings, fitting subjects to design constraints, generating new documentation, changing notification and so on. Intelligent healthcare networks as well as telemedicine will involve doctors collaborating among themselves, analyzing multimedia patient data and information in real time as it is generated. All these next is the data management issues. Multimedia application deal with thousands of images, documents, audio and video segments and free text data. Depend critically on appropriate modeling of the structure and content of data, and then designing appropriate database schema for storing and retrieving multimedia information. Multimedia systems are complex and embrace a large set of issues which include the following. Modeling firstly. This area has the potential for applying database versus information retrieval techniques to the problem. There are problems of dealing with complex arrays made up of wide range of data types of data: numeric, text, graphic, animated graphic, image, audio stream, and video sequence. Documents constitute a specialized area and deserve special consideration. Design. The conceptual, logical, and physical design of multimedia database has been addressed fully, and it remains an area of active research. The design process can be based on general methodology described, but the performance and tuning issues at each level are far more complex. Storage of multimedia data on standard disk-like devices presents problem of representation, compression, mapping to device hierarchies, archiving and buffering during input-output operations. Adhering to standards such as JPEG or MPEG is one of the most vendors of multimedia products are likely to deal with this issue. In DBMS, binary large object facilitate allows untyped bitmap to be stored and retrieved. Standardized software will be required to deal with synchronization and compression decompression and will be coupled with indexing problems which are still in research domain. Query and retrieval. The database way of retrieving information is based on query language and internal index structures. The information retrieval relies strictly on keywords or predefined index terms. For images, video data and audio data, this opens up many issues, among them efficient query formulation, query execution and optimization. The standard optimization technique is needed to be modified to work with multimedia datasets. Performance. For multimedia applications involving documents and text, only performance constraints are subjectively determined by the user. For application involving video playback or audio-video synchronization, physical limitation dominate. For instance, video must be delivered steady at rate of 30 frames per second. Techniques for query optimization may compute expected response time from evaluating the query. The use of parallel processing of data may alleviate some problems, but such efforts are currently subjected to further experimentation. Thank you.